There's a whole bunch of photographs in the talk. I'm just doing a little bit of admin at the moment, really. Those are the photographers. I have permission to publish all of them. There's video DVD stuff at the bottom. I won't be using video in this particular talk because it doesn't come across very well in Zoom. But if you really want to see them, then I'll send them. I'm happy to send them via email. This is my brief history. I've been an aero modeler since 58, private pilot since 67. I got my private pilot's license 2 years before my driving license, which seemed logical to me, but it didn't really seem logical to most of my colleagues. I learned to glide in 69. In fact, Tony Dring referred to me as an instant statistic when I pitched up at the gliding school. He was one of the instructors. Because I'd already got my PPL, so it would be a very quick job to get my A and B certificate, which I did. I did 20 years in the Air Force. I've done 30 years in industry with Rolls-Royce and Marshall Aerospace. I'm currently flying part-time for Marshall Aerospace, flying Hercules for the Royal Air Force. I'm too old to do revenue earning stuff. I can only do test flying. I learned to be a test pilot in the Air Force on the French test pilot school. And that set me up really for my civilian career. Rolls-Royce got me into display flying. I put one of the bullets PFA test pilot because I was at the time, and you were the PFA at the time. Obviously, eventually came the LAA, and I continued test flying for the LAA. I put instructor, but it was really one of the coaches. I was chief coach for the southwestern area for a time, and an R examiner from mid 1990s up to about 2011, when I sold my Jodel and left the LAA. Historic flying I've done since 84. I've owned my own aircraft since 90, and that's about it that's relevant, I think. So people always ask me what my favorite airplanes are. I've flown about 170 types, which is not that many for a test pilot of my vintage. And I've got about 8,000 hours, which is, again, not many for somebody who's been in aviation been a professional pilot for 52 years now. But the favorites are obviously Spitfire, Blackburn 1912, and Harrier. I don't have a single favorite airplane. Though I have to say the Harrier is the most fun. That particular aircraft, I got 2 world records in 1989, time to climb, 36 seconds to about 10,000 feet, and 81 seconds to 30,000 feet in August 89, and they still stand 32 years later, which is rather nice. We can talk about that later if you want. Right, flying historic airplanes. People say, isn't it dangerous flying old airplanes? No, it's not. It's different, but it's not dangerous. If it was dangerous, we wouldn't do it. The CA wouldn't let us do it for starters, but we do the risk assessments, obviously, and get the risk down to the minimum level. And in many respects, it's safer than, well, I won't say it's safer than light aircraft flying, because it is light aircraft flying. It's just the same. What you've got to do is put it into context. Edwardian aircraft, the first aeroplanes that were around, were designed, built, tested, flown at the same time as the designer was learning to fly. And they had no prior knowledge apart from maybe building a few model airplanes. And they managed it. If they hadn't managed it, we wouldn't be where we are today. And with minimal training, I see Anthony Dring is on. I've got his name come up. With minimal training, aircraft was successfully taken to war by teenagers. And we've read the book, so we know that. So they can't be difficult, but they are sufficiently different from modern airplanes to make them not high risk, but you've got to unteach modern techniques and teach the old stuff. And that's really what my job at Shuttleworth was making sure we'd got a set of pilots that could safely fly and demonstrate the airplanes. So what I'm going to do today is look at examples of specific flying techniques that are applicable to some of the Shuttleworth airplanes. I won't go through every airplane because it would take too long, but we'll look at four particular handling types that are perhaps different to what the normal LAA pilot would be used to. So wing warping, that was the description of it that I got from my predecessor of chief pilot at Shuttleworth, and it'll never replace the aileron. Reason being that you get an awful lot of adverse yaw, and we can look at it with the Blériot 11. That's the Blériot 11. Lost my headset because I trod on the cord. Let me just put that to the back of my computer. Right, that's the Blériot 11. It's the oldest flying aeroplane in the world. The old Rhinebeck in the States thought they had the oldest one, but our construction number was slightly lower than theirs, so they've admitted that this is the oldest one. It's a little bit like the Favourite broom, though, in that it's had 5 new handles and 6 new heads, but it's the same old broom as it always was. The engine, I think, is still original, but a lot of the other stuff has been, shall we say, changed over the years. But it's still got the same construction number. Now, looking at the flying of the airplane, the yaw is controlled by rudder bar, rudder at the back. The elevation is controlled by an elevator. And again, you've got elevators at the back of the airplane. But the roll control, as you would understand it, is done by wing warping. What happens when you wing warp? Let's see what the next slide is. That's the cockpit, and you've got a control column in the middle. At the bottom, that bell-shaped thing is called la cloche, which is French for bell, spookily enough. There's a bell crank under that with wires leading to the elevators and the ailerons, correction, the wing warping. And there's a rudder bar just in front of the cloche that you can see. So it's conventional flying controls. To operate the airplane, we might as well have a word on that now. There's the only gauge that you can see is to the left of the tank at the front, which is an oil pressure gauge. The oil pressure is pilot controlled, and you control it by pumping up the pressure in the oil tank, which is that pump on the right hand side of the cockpit. And on the top of the oil tank, that copper thing in the front of the airplane is a valve to blow off air, and at the bottom is another valve to allow oil to flow to the engine. On the control column, there's a lever to the right of the control column, which is the advance and retard. Fully forward to go slow and fully back to go fast, which is opposite to the way you would normally expect it. And in fact, the French, up until World War II, all of their throttles operated in the reverse sense. You pull it back to go faster and you pushed it forward to go slow. And the Hurricanes that we sent to France at the beginning of World War II were modified so that their throttles operated in the opposite direction. Sometime during World War II, the French came into line with everybody else and have their throttles operating conventionally. And that is the only example I can ever find. And I lived in France for a year doing the French test pilot course. The only example I could find of the French coming into line with the rest of the world. So store that one away. Anyway, that's an advance and retard, which gives you a modicum of engine modulation. The way the engine is run is that the ground crew fill each cylinder with a fuel air mixture. They spin up the prop a few times to distribute it. Pilot then, when he's ready, sets minimum advance and retard, i.e. lever forward. The ignition switch is on the left-hand side of the cockpit. You turn that on, call contact, the engineer flicks the prop, hopefully it starts. You then adjust the oil flow. You need about 1.5 to 2.5 psi on the pressure and about 1/4 to 1/2 of a turn on the cock at the bottom of the tank. You adjust the oil pressure so that at one end you don't want the engine squeaking, and at the other end you don't want the engine coughing and spluttering because it's got too much oil. It's a total loss system, so there's no doubt the oil is flowing because it comes straight back in your face. And to answer the obvious question, yes, you do get a bit loose over a couple of days, but you know, it soon passes. And that's how you operate the airplane. You adjust the oil flow, you adjust the advance and retard to get the maximum noise, you drop your hand, they let go of the thing, and off it goes. Now, let's have a look. That's the engine control. Let's have a look at the aerodynamic controls. Coming back to the airplane, when you warp the wing, if I put the control column to the right, then the incidence on the left-hand wing will increase, the incidence on the right-hand wing will decrease. If you look at the angle of attack of the wing, it's around 12 to 15 degrees. So if I increase the instance on that wing, it's going to stall. And if it stalls, then that wing is going to drop. So if I put my control column to the right, intending to roll to the right, the left wing instance will increase, the left wing will stall, and the left wing will drop. So the primary effect of right stick is left roll. Further, because you're increasing the instance, you increase the drag. And if you're decreasing the instance on the other wing, you decrease the drag. The increase in drag will cause the aircraft to yaw towards the lowered wing, which means the secondary effect of putting the stick to the right is yaw to the left. And with that amount of dihedral, the tertiary effect is roll to the left. So if you put the stick to the right, the aircraft will go to the left. Now, Blériot's grandson intended to fly one of his grandfather's aeroplanes across the Channel to the United Kingdom to celebrate his grandfather's historic flight. And the aircraft crashed. Luckily, it crashed on the airfield boundary before he got over the Channel. And he said, it wasn't operating and answering to the controls. When I put the stick to the right, it rolled to the left because he flew it like a modern aeroplane. I don't know if you're aware, but in those days, people used to fly the aircraft using the rudder for direction control. If you want to go left, you put rudder left. If you want to go right, you put rudder right. And if you read the books, it says when you've got a lot of bank on, you use the elevator as a rudder, i.e. you put a lot of bank on, you use the elevator to turn. But initially, if you want the aircraft to turn, you put the rudder on. And if you use the rudder on this aeroplane, if you want it to roll to the right, you put a squeeze of right rudder on. Because of the dihedral, you get a nice rolling effect. So the way to fly the Blériot is to ignore the wing warping and fly it on rudder and elevator only, a bit like a model airplane, and then it flies perfectly safely. So that's the first old technique that you have to unteach pilots, or that we're going to look at today. This is an aircraft that only the experienced Shuttleworth pilots fly, but that's the first technique for flying old airplanes is don't use the roll control, use the rudder and the elevator. There's a nice little anecdote really that goes with that. If you look at pilot's notes, if you like, for the First World War rotary powered airplanes, it says always circuit to the left, always turn to the left after takeoff, never turn to the right. The reason is that the way the rotary engine, they all rotate in the same direction, which is left-handed, i.e. goes anti-clockwise when you look from the front. Then if you yaw to the left, the nose will go up. If you yaw to the right, the nose will go down. So if you take off and you stop with camel and turn to the right, you turn on the rudder, put right rudder on, the nose will go down and you'll crash. So the technique is as soon as you get airborne, you put left rudder on, the nose goes up and you climb away. And that is why nowadays, the primary direction for the circuit is to the left, because they always flew to the left in the First World War. There you go, bit of history as well. That's what happens when you don't get it right. This particular pilot was taking off at Old Warden. The right wing dropped, so he put left stick on. And if you look in the cockpit, you can see his hand has got full left stick. He's also got full left rudder as well, but that's too late. Full left stick caused the right wing to drop, and Randy went on a ground loop. And that's what it looks like when you get it right and you fly it on the rudder. Now, there would be a video at this point, but I'm going to skip through that because they don't come across very well on Zoom. So going on to the next airplane, I'll let you read these handling characteristics come straight from the aircraft's pilot's notes that were issued to the pilots that flew them in the Royal Air Force. So it is a Royal Air Force airplane, but I'll let you read what the handling notes say, and then you can have a guess at what the airplane is.
Oh, yeah. guess it's the Lysander because of the elevator trim.
I was going to ask that at the end.
I'm sorry.
That's all right. But you're absolutely right. It is the Lysander. Are we done? Yep, good. Thank you. And there we go, Western Lysander. So why is it like that? The Lysander is one of my favorite airplanes. Second favorite, it's not first favorite, it's obviously. It's a remarkable airplane. I gave this talk to Westlands 20 years ago now, and I said the Lysander is a remarkable airplane. Some of it's remarkably good, some of it's remarkably bad, but there's very little in between. And I got a very funny look from the chap at the back, who was one of the design team from 1930 on the airplane. So you got to know your audience, really. Let's look at the bad things. Really, are the handling characteristics. The handling characteristics are they're not dangerous and they're not bad, but they are quite a trick, and I'll talk about that in a minute. But the good stuff, if you look at the pilot's eyes, it's level with the wing, so you've got a good field of view. It's not cockpit visibility, it's cockpit field of view. Visibility is the distance you can see. Field of view is what you can see. So there's a good field of view in the Lysander. You're on the wing chord line in effect, so you can see above or below the wing. So you've got a good field of view to the rear. The pilot sits quite high, so you can see over the nose. It's one of the few tail draggers that you don't have to weave, because you can see in front of the airplane. And because it's a relatively narrow cockpit, you can see either side as well. So very good field of view from the cockpit. What else is good? It's got a long range. There's a 90-gallon tank in the fuselage. You can see that just behind the pilot. When you put that big tank underneath it, you've got a range. It'll cruise at around 150, 160 miles an hour at around 30, 40 gallons an hour. You've got a 150-gallon drop tank underneath and a 90 gallons in the fuselage. So what's that? 150, 90, 240, 30 gallons an hour. You've got an 8-hour endurance at 150 miles an hour. So quite a considerable range out of the airplane. It's got a good stall performance. The engine is 860 horsepower. Yeah, it's got quite a large engine in it. It's 860 horsepower, which is a bigger engine than the Hurricane, funnily enough, and I'll talk about that some other time. Hurricane is 840 horsepower at sea level, goes up to 1,000 horsepower at full throttle height of 11,600 feet with the Merlin 3. But the Lysander, same as the Gladiator, has got 860 horsepower. So quite a powerful motor there. I'm going to go next slide. I'm not sure what to. Yeah, it's although it looks stubby and fat, it's quite low drag. If you look at it from the front, as you can see here, there's not much to it. So that's why you get such a good fuel consumption and such a high cruise speed, that it's a relatively low drag airplane. Quite underrated, actually, in many respects. So handling characteristics. It has automatic slats and flaps. The inboard slats are connected to the flaps. So when the inboard slats come out, the flaps go down. And they are connected, cross-connected as well. So you'll never get asymmetric flap, which means you don't have to worry about flap limits, because when you pull incidents, the slats come out and the flaps go down. But as you speed up, then the flaps will blow back in again. So if you're in a hard turn at speed, if you're within the flaps limit, they'll come out. If you're not, they won't. And when you slow down, the flaps will come out, which means you just don't really have to think about it. You've got to get to aircraft like the Eurofighter before you get such an elegant automatic flap system. And this is all done on with mechanics and aerodynamics. The outboard slats are independent, but they do tend to come out together. If they don't come out together, it doesn't matter. You don't get any significant roll control. Now, the aircraft is very stable, which means it's quite heavy in pitch. which means you've got an all-flying tailplane. And if you look at the tailplane at the back, you'll see that there's 3 markers on the front of it to indicate the tailplane trim of tailplane up or tailplane down or tailplane neutral takeoff position. On the back of that, you've got an elevator that's connected to the control column, which gives you pitch control around those positions. Now, in order to get adequate pitch for takeoff, you need the tailplane in that middle white mark position. When you're doing an approach, and this is the aircraft at exactly the same speed, at exactly the same angle of attack, you need full up tailplane, i.e. with the tailplane nose down on the bottom position. Now I'm just going to go back again to that one. When you take off, in order to get a short takeoff with the aircraft, you take off with the stick fully back, because if you raise the tail, you'll reduce the incidence on the wings and the flaps will blow in and it'll increase your takeoff run. Now the takeoff speed is around 80-85 miles an hour. The stall speed is something like 40 or 50 miles an hour. So you're way above stall speed. So you can take off with stick fully back quite safely. So you take off in the 3-point attitude. You don't bother to raise the tail. You put stick fully back. As the aircraft lifts off, you start easing the stick forward and start trimming forward in order to get the aircraft to fly away. And because you take off in a 3-point attitude and you land in a 3-point attitude, the incidence on the airplane, on the wings, is exactly the same. But in order to maintain that incidence, when you take off, you only need half of the tailplane nose up, i.e. tailplane nose is down, but that gives you nose up change. Whereas when you're landing, you need all of it in the nose up position. So why is that? I'll let you think about that for a few seconds. And I say it's because when you take off, you've got 860 horsepower energizing the tailplane. And when you land, you've got very little horsepower energizing the tailplane. So in order to get the same pitching moment, you need a lot more tailplane. Now that means that between takeoff, if you take off and get an engine failure, when you get airborne with the tailplane energized, that is the trim position of the tailplane. If you get an engine failure, in order to trim the aircraft, you've got to get the tailplane in that position. And that is approximately 23 pulls on the trim wheel, which takes a finite amount of time, which is why the pilot's notes say up to 1,000 feet can be lost if you get an engine failure. Sorry, up to 600 feet can be lost if you get an engine failure on takeoff. It's quite logical. So the way around it is you get airborne in the 3-point attitude. As soon as the aircraft breaks ground, you then start feeding the stick forward and moving the tailplane trim forward. And you keep the aircraft in ground effect until you've got about 100, 120 miles an hour. And you can then climb away quite safely because then you've got enough energy to be able to cope with an engine failure. If you do a steep climb out, which is what they had to during the war, again, it says in the pilot's notes, that can be a bit of a trick. So, in fact, I'll just come away from that one. The next challenge is getting the aircraft back on the ground. And this is the fun one. When you come on the approach, if you're, let's say you're 50 foot high, no, we won't say 50 foot high. Let's say you're slightly high on the approach. What you would do in a standard airplane is stick the nose down to achieve the right approach path. If you put the nose down in the Lysander, your speed will increase, the incidence will reduce, the flap will blow in, and then when you pull the nose back to stop your descent, the flaps will come down, the aircraft will balloon, and you'll end up 50 foot higher than you were before. So in order to lose height on the approach, if you're high, you pull the stick back to increase the drag to get more flap so that the aircraft then descends onto the glide path. And when you're on the correct glide path, you put the nose forward and fly and continue as normal, which is dead against normal practice. But it's quite safe because you're about twice the stall speed. So you're so far away from the stall that it doesn't matter. And you can safely pull the stick back on the approach. So that's the Lysander. Good characteristics and challenging. There's no such thing as a bad characteristic. Good characteristics and challenging characteristics. I remember giving a briefing to the excuse me, United States Marine Corps. When I worked for Rolls-Royce, they were crashing Harriers, and we had to go out there and explain how to operate the Harrier engine, and trying to tell Marine Corps pilots how to fly their airplanes was a bit of a challenge for a Brit, but we did it. And I was working with McDonnell Douglas, and I put up a slide that said anomalies of the digital engine control. And he said, digital engine control does not have anomalies, it has characteristics. I was like, okay. So I had to change the slide. There we go. So there's no such thing as bad things. There is characteristics. Interesting characteristics and good characteristics. Right, next airplane. This is what the pilot's notes say. The ATA is the Air Transport Auxiliary. Those are the people that flew the aircraft around, delivered the aircraft during the war. Just checking the time. How are we doing? About halfway through. Okay, that's good. All red? There's a few more. Any ideas what it is yet? Now, this is what the pilot's notes say. Having read all those Martlesham-Heath experimental reports, this is what the pilot's notes say, and it is an absolute lie. It's not. It's the Hurricane Mark 1. Not my favorite airplane for various reasons, but it is unstable in pitch. We thought we'd got something wrong with the airplane. In fact, I did the first flight of the shuttle with Sea Hurricane in 1995, and it was grossly unstable in pitch. We'd screwed up the center of gravity, and it was about 100% behind the aft limit. But even when we got it within the correct limits, it's still unstable in pitch, and we were trying to find out why. This was the only Hurricane 1 on the circuit at the time. And I was working for Rolls-Royce, went to a dinner with Bill Pegg, who was the Brabazon test pilot, and asked him. I said, have you got any experience of Hurricanes and Spitfires? And he said, yes. What about testing? Yes, he had. So I said, well, what about Hurricane stability? And he looked down his nose at me and he said, everybody knows that the Spitfire gets its maneuverability from aerodynamics. The Hurricane gets it from instability, which was true. So it is an aircraft that's unstable in pitch. So why is it unstable? Tailplane's too small. CG's too far off. The tailplane actually is very small. It's got the wing section on the Hurricane is the Clark YH, which has got quite a strong pitching moment. With the small tailplane, it is unstable in pitch, and even more so if you put a bit of yaw on, you blank one side of the tailplane, and you end up with quite violent pitch down. So trying to navigate the thing is a pain, because on these airplanes with long noses and quite wide wings, the only way you can see down is to put a bit of yaw on and look to the side of the nose. So you're looking out the front of the airplane trying to navigate, you put a bit of yaw on, and next thing you know, your head's thumping the canopy because it's gone into a bunt. Awful thing. Anyway, there we go. What more can we say? I'm going to leave it at that on the Hurricane, I think, because of time. Yeah, let's leave it at that. Just let's say that the Hurricane is a challenge to fly. If you're doing a cross country, then you've got to fly it all the time. There's absolutely no doubt. They say it's a steady gun platform. In fact, it was a very maneuverable airplane, and it would be good in combat because it's relatively easy to get the sight onto the other aircraft. Once you've got it there, yeah, you'd have to put a little bit of pitch input in to keep it on there. But as a fighting aircraft, yes, it is probably very good. But as an aircraft for pure flying, it's just hard work all the time. Right, I'm going to go now on to rotaries, which is one of my favourite areas. We'll do this for about 20 minutes, then we'll go on to questions. So the rotary engined aircraft, as far as the pilot is concerned, is the Shuttleworth Collection Sopwith Pup. I'll tell you a little story about this. I was in the Air Force. I was on 54 Squadron from 1975 through 1978. We were flying Jaguars. We had our 60th anniversary in 1976. We had obviously a weekend of celebrations. The original squadron boss, a Major KK Horn, and his adjutant Captain Charlie came to our 60th anniversary celebrations. They formed the squadron in France on Sopwith Pups in 1916. We also had a lot of the First World War ground crew there as well. A lot of Second World War people too. Bill Hooper, who was the creative pilot officer Prune, member of 54 Squadron. Pollock, the guy that flew the Hunter under the Tower Bridge, he was a member of 54 as well, so we got to meet him. But going back to KK Horn and Captain Charlie was a little guy. He was about 95 at the time when we met him, and probably about 5'2", 5'3", little chap with a shock of white hair, a bit like mine. Well, if you could see mine, you'd see it was white. And he gave the speech after dinner. He gave 3 anecdotes, and unfortunately I can only remember one of them. And he said, and I quote, he said, "In retrospect, it was probably a silly thing to do." He said, "But in my defense, it was after a particularly drunken night in the mess, and I did win the bet. I do believe I am the only person ever to fly a Sopwith Pup stark naked over the Western Front," which we all thought was absolutely fabulous. The following day, we showed the ground crew guys around the hangar, and there was about 6 or 7 of them, all in wheelchairs, all in their 90s, and they were being pushed around 54 Squadron hangar at Colt with all the Jaguars. And one of the guys looked at our airplanes, and he looked at me, and he said, "I've got a question, young man." And I said, "What's that?" He said, "How often do you crash your machines?" Because they called them machines in those days. And I said, "Well, not very often at all, actually." And he said, "Really? We used to crash ours every day." So how the other half lived. Anyway, Sopwith Pup. Sopwith Pup has a rotary engine. This is the fuselage of the Shuttleworth Collections Pup. The crankshaft is attached to the fuselage, and the engine rotates around it. I've got on the right hand side of the picture, you'll see the word crank. That is pointing really to the back of the engine, not to the front. In the middle of the picture, you should see an air intake, an arrow going to the air intake, that tube that's sticking out the left-hand side of the picture, out of the right-hand side of the airplane, but the left-hand side of the picture. The carburettor is a T-piece in the middle of the aircraft where those intake tubes meet the tube that runs to the middle of the aircraft through the hollow crankshaft. The fuel air mixture is collected in the center of the engine, and then it goes up the fuel air distribution pipes to the inlet valves, and you can see the pipes, those brass-shaped thing, brass curly things that are on the front, and the fuel is taken into the cylinders and then fired as normal. So, characteristics. This is the Sopwith pump petrol system. It's pressurized. There's no venturi in a rotary engine carburetor, so there's no suction. So you have to pressurize the fuel tank, and it's done with a Rotherham propeller pump, which is a pressure pump, or a hand pump. There's a relief valve, there's a pressure gauge so the pilot can monitor it, and the pilot can control the relief valve so that it doesn't overpressure. There's a fuel clock, which then takes the fuel to 2 levers that the pilot controls. The one is the needle valve or Tampier filter tap or fuel air lever. It's called one of those 3 things. And the other one is the fuel control, which is at the carburetor end, if you look on the left-hand side. And the Tampier filter trap controls the fuel air mixture going to the engine, and the fuel control controls the fuel that's going to the fuel air mixture. And that then goes to the engine and it runs. So this is the cockpit of the pup. On number 1 on the right hand side is the pressure pump to pressurize the air system. Number 2 is the altimeter just to the left of it. Below that you've got airspeed, which is marked, should be marked number 3. Yes, it is. Number 4 to the left of that is a ignition switch. Number 5, the control column. Top of the control column, you've got a button that controls the ignition. You can kill the ignition of the engine using that button. Where's number 7? That's the rudder bar on the floor, a standard rudder bar with a couple of footrests for your heels running either side. At the top, number 8 is a compass. Number 9, that's a level indicator, which is an upside down turn and slip. If you use it as a turn and slip, it doesn't work because you put the wrong rudder on. But if you fly the aircraft using the rudder and using the control column to move the ball into the center, it works, which is another indication that you fly the aircraft using the rudder. Well, the intention was to fly the aircraft using the rudder to turn it and use the control column in roll to balance the turn, whereas we would use the control column and use the rudder to balance. So it's a bit I was going to say arse about face, but I shouldn't really. There we go. Number 10 is RPM. You need to monitor that all the time. If it goes too much, you'll start shedding bits off the engine because the centrifugal force. If it goes too slow, you're not getting any power. 11 is the oil pulsator. It's essential that you get oil going to the engine. So that pulses up and down while oil is flowing, and you're supposed to monitor it. But a bit like the Blériot, you're in no doubt that oil is flowing because it gets thrown out the side of the engine and it comes back into the cockpit. Number 12 is the fuel on-off switch. 13 is the air pressure gauge. I'm on the left-hand side of the cockpit now. And 14 and 15 are the interesting bit, which is the pilot controls. So let's look a little bit more at those. Pilot controls, he has 2 levers. Number 14 is the fuel air lever. That controls the amount of fuel and air going to the engine. Number 15 is the fuel lever, which controls the amount of fuel that's going into the fuel air system. They go in a quadrant that's marked from 1 to 10. You can't see the marks on there, unfortunately, but you'll see an indicator on the point of lever number 14, the fuel air lever, that is pointing to the quadrant so that you can note the position of the lever at any time and note it down. Going to the right of that, you see the air pressure gauge is redlined at 2.5. So if it goes above 2.5, then you need to turn the air down a little bit. Right, the block tube carburetor. This sits in the T-piece. You've got the intakes coming in from either side of the fuselage. And this is at the T-piece in the middle where the fuel is mixed with the air. Top right, cockpit control. That's the lever that the tall lever in the cockpit. That controls. It's called a block tube carburetor, and if you look in the middle, you'll see a needle valve marked. Needle valve is attached to a slab of metal that moves across and either opens or closes the intake area. And that's why it's called a block tube, because you're blocking the tube. And as that lump of metal moves across, it either opens or closes the air inlet, but at the same time, the needle valve increases or decreases the fuel flow. So that's why it's called a fuel air lever, because it controls the amount of fuel and air. The amount of fuel that goes in, if you go to the left-hand side, it's got fuel in. The amount of fuel that goes into that area is controlled by the little lever. So if you turn the little lever off, there's no way you'll get any fuel air going to the engine. If you pull the little lever fully forward, you'll get far too much fuel going into the engine. But because you've got this needle valve and the block tube, you've got a little bit of modulation of engine power using the tall lever. Looking at it from above, then you can see the air intakes going across the cockpit, across the top of the picture, where it says air in. In front of that, you've got the block tube, which is the lump of metal that goes across that blocks it off or opens it up, and the fuel coming in from the left-hand side. And at the bottom, the fuel air mixture going to the engine. Now, on the left-hand axis, you've got the petrol lever or fine adjustment, which is the little lever. And at the bottom, you've got the position of the block tube. And we operate it between 0 and 10. So let's say 0 and 10% in both cases. And if you look on the bottom, with the block tube, the big lever at 30% and the fuel in the right lever in the right place, we get about 800 RPM. As we move the block tube forward to 70%, provided we've got the fuel in the right place, we can get up to 1100 RPM. So we can modulate our rotary engine between 800 and 1100. 800 is enough for level flight, 1100 is good for a climb. So you can't descend with the engine running. In order to descend, you've got to turn the engine off. But we'll talk about that in a minute. How do we run the engine? So looking at diagram A, top left, we set the fuel lever to 0 and we set the block tube lever number 14 to a position for roughly 800 RPM running. The ground crew will prime each cylinder in turn, spin up the throttle the prop a few times to distribute the mixture, call contact, pilot calls contact, turns the ignition on. The ground crew then spin the propeller, the engine will fire up and it will burn off the prime and then it'll stop. So it'll make a noise like, and then it'll just coast. Before the engine stops rotating, you move lever 15 forward and so it's in position B to introduce fuel into the engine. You then modulate position the lever B to get smooth running. If you go too far forward, you put too much fuel in, the engine will stop. If you're in the air, it will take 30 seconds to clear. If you're on the ground, you've got to blow it all out and start again. If you move the lever too far lean, the engine will stop. But if you're on the ground and you move it forward quickly, you can often get the engine back again. And if you're in the air, same thing. You warm up the engine for about 30 seconds around 800 RPM. Rotaries will overheat on the ground. You shouldn't run them for more than about 2.5 to 3 minutes. So you have to be relatively quick getting the lever positions. You then move the block tube forward, the tall one, as in C, to the fast running position. And I'll show you in a minute that that will cause the engine to stop. You then bring the little one forward to get the right fuel. Once you've then assessed the engine running at high speed, 1100 RPM, you note the position of the levers. You then move the fuel back, which turns the engine off, as in D. You move the block tube back, so we're now on position A again, and you then move the fuel lever forward to get the engine running smoothly at low RPM. You then signal the ground crew to remove the chocks. At this point, if you don't kill the engine on the ignition, the aircraft will jump forward, hit the ground crew with the leading edge on the head, and there's no way you'll get a start later on that day. So you chop the engine using the blip switch on the throttle to reduce the power. Once the chocks are out the way, you can let go of the blip switch. You're now running at about 800 RPM and you start to trundle down the runway. You then go to position C, move the block tube, the fuel air lever forward, move the fuel lever to the point that you noted when you're doing your engine run to give you maximum power for the takeoff run. Now, if you do nothing, the engine will quit about 50, 60 feet after takeoff, because as you accelerate down the runway, the propeller unloads, the engine RPM will increase, centrifugal force will enrich in the mixture, and the engine will have a rich cut. So as you're accelerating down the runway, you have to move the fuel lever back. When you're climbing and the air gets thinner, if you do nothing with the fuel lever, the engine will quit. So as you climb, you have to move the fuel lever back. As you descend or decelerate, you move the fuel lever forward to keep the engine running. If you want to descend, if you use the blip switch, then you're shock loading the engine every time you do it. So it's not recommended to use the blip switch while you're in flight. You can use it on the ground at low RPM, but not to use it at high RPM. Also, if you use the blip switch for a prolonged descent, you're still putting fuel into the engine. So when you release the blip switch and turn the ignition back on again, you'll probably get a fire. So in order to descend, you turn the fuel off. So every single landing is a forced landing without engine, and you set it up at low key position. When you're certain of getting in, then you turn the fuel off and you aim for the middle of the field. You only need in a Sopwith puff about 30 yard of landing run, so there's no major issue about plonking it back onto Old Warden, which is a 600 yard runway. Although it is essential to land into wind. If you don't land into wind, you'll end up into wind plus a bit afterwards, because it ground loops like you know what. And the technique is to get into the low key position, turn the fuel off, glide around the corner, and in the latter stages of the approach, slowly bring the fuel in to get the engine to pick up. But before it picks up, you kill it on the blip switch, so that when you touch down, if you need the engine to correct a swing or anything like that, you've got no brakes. So the only way to correct a swing is to use the rudder. You take your finger off the blip switch and you should get a bit of engine to help you control the landing. On the subject of swinging, if you do a wheeler landing, you will ground loop, because you've got quite a lot of rotating mass up the front, a lot of centrifugal, a lot of gyroscopic precession. So as you lower the tail, you'll get a yawing moment, which will cause a ground loop. If you raise the tail too quickly on takeoff, you will get a ground loop. One of my colleagues in the Shuttleworth, whenever he flew the pup, he said, I always aim 30 degrees off where I want to go, so that when I raise the tail, it swings 30 degrees to the left, and then I know I'm down the runway. I just shook my head. I did. Anyway, that was that. So looking at it on the diagram, that's the idle position. You've got to be within those two white lines to get smooth running. If you're above the upper white line, you'll get a rich cut. If you're below the lower white line, you'll get a lean cut. So once you've got it running at 800 RPM, if you increase the fuel, then the engine's going to quit because you've got too much fuel going in. So you increase the RPM by moving the block tube forward, but because you're by then below the bottom running line, the engine stops. So you then move the fuel in to get smooth running again. Same for decelerating. When I decelerate, if I decelerate by moving the large lever back, then I bring the engine into a point where it's got too much fuel going in. So in order to decelerate, I turn the fuel off, I then move the big lever back, and then I put the fuel back on again. So you spend quite a lot of time with no fuel going to the engine, with the engine off effect in flight, which is quite interesting. Questions I often get are, it's so complicated, how on earth did they do it? Well, this was the way they operated engines in those days. They had ground running rigs that pilots would play with for hours and hours and hours until running the engine was second nature. When you've flown a few trips on a rotary engined airplane, in fact, you end up with second nature. You end up with your fingers around the tall lever and your thumb operating the petrol lever on the inside. So you're working the tall lever like that and the petrol lever with your thumb like that, and it becomes intuitive. You can feel what the engine's doing through the airframe. When it's too rich, it feels very heavy, it starts to thump. When it's too lean, it coughs a little bit and starts getting a very light note. So you can move the fuel to get the sweet spot, as it were, to get the right sort of power. This is my favorite rotary powered airplane. Absolute delightful. It's the only shuttle collection airplane that is stable about all three axes. All of the other aircraft are unstable around at least one axis. And this is the oldest flying British airplane. There we go. I'm going to leave that because it's not relevant. Right, that's the end of the talk. So I will finish to say it is not difficult, but it's certainly different. There we go.
Oh, that's great. Thank you very much, Andy.
Questions?
Fascinating. I've got.
Was that what you wanted?
Well, I was happy with
what
that.
You got.
I was interested to hear that.
Have a drink now. Cheers.
Your favourite aircraft was the Harrier.
Yeah.
I've got a friend who's got a GR3, and it's a runner. So if you want to have a go, but we've got to get it back. We took it to bits just before lockdown, so there's a bit of work to do on it. But if you want to have a go, let me know.
Oh boy, I'll tell you what, I'd love to, but I made the decision. I'm 71 now. I made the decision at 50 that I wasn't going to sit on a bang seat again.
It's all right. It's inert.
That was the last bang seat flight I did was in a Jaguar, which is now hanging up at Duxford, which was in June 2000. And then I made the decision I wasn't going to fly bang seats again, so I then moved to Marshall Aerospace, and since then been flying Hercules.
Right.
It was much more fun because you've got a toilet, which is great at my age. You've got a galley. There's a fridge on some of them. There's a microwave on others. Yeah. What more can I say? You don't get that in a Harrier.
No. Well, if you want to reacquaint yourself with the Jaguars, we've got a few at Cosford.
Yeah, I have to say, I used to. Oh, cracky! Is McLean? Al McLean, is he still there?
No, I don't think so. I don't remember.
He was a curator. Alan.
I know what you mean. Yeah. No,
Alan and I went through university together many years ago.
Oh right, yeah.
So,
yeah.
and we're also went through pilot training together at Cranwell back in '73.
Right.
But there's 5 aircraft I think at Cosford that I've flown.
Wow.
Which is the LVGC6, the Bacara, the Nat, the Hercules, and the Varsity.
Right. Gosh.
So I'm flying the actual aircraft, not the type. So,
right. Yeah. I can see Ian Gordon's got a question.
Well, that was fascinating, especially the Sopwith pup. Particular interest in that because on the wall here, I've got a Sopwith Camel propeller.
Oh, lovely.
And at one stage, I had a rather silly idea of attaching it to a Sopwith Camel and learning to fly a Sopwith Camel. But presumably the Camel is similar to the pup, is it?
I've not flown a Camel, but I assume it's going to be like an overpowered pup, because the Camel had 130 Clerget minimum in it, whereas the pup's only got 80 horse to their own. So pup is a delightful airplane. It's a lovely airplane to fly, very light on the controls, whereas the Camel's a bit of a brute, I hear.
And caused quite a lot of pilot deaths, I believe. Oh.
Very potent airplane though.
Thanks, Andy.
You're welcome. What was the Bacara like to fly? It was fun. I've just seen that in the chat box. Who wrote that? Graham Preble. Where is he? Say something, Graham. Then I know where you are.
There he is.
Where is he?
You're on mute, Graham.
I'm on. Oh, hiya.
Gotcha. Right. I can see I'm talking to now, which is rather nice.
Yeah,
it was.
I met one of the Harrier pilots from the Falklands, and he rated it quite highly. So
yeah, I didn't do any combat in it. We were just doing we got one of the captured airplanes at Boscombe Down while I was there. We all had a go in it. It was quite pleasant to fly. What more can I say? Cockpit field of view was good, so good for ground attack. Handling qualities were good. I couldn't find anything really to criticize the airplane on, except perhaps that it was a bit slow when compared to aircraft that I was more used to. But the sort of speeds that you'd get from an A10, in the lower end of the bracket rather than the higher end of the bracket. But quite a potent airplane, and certainly our ground forces treated it with a lot of respect during the Falklands War.
So, question in the
Did
chat.
the well set the power before going into combat, or were they experienced enough to adjust in combat? When you're flying an airplane and you've got a lot of time in an airplane, it comes naturally. Do you think about when you fly your light airplanes, do you think about what you're doing with the throttle? If you're doing something with the airplane, do you think about what you're doing, or do you just do it naturally? And we all know what the answer is to that, specifically when it comes to handling the controls, stick rudder and aileron pitch and yaw. And when you get used to the operating a rotary engine, the left-hand movements become instinctive. So they would almost certainly, when you're going into combat, you set full power and leave it there, but they would be modulating the engine with their left hand as they required it, in the natural way that you would use the throttle to give you the power that you require at the time. Is that it?
There's another question there. Steve's got, was the water-cooled engine in the SE5 an advantage or disadvantage?
A bit of both, really. You didn't get the disadvantage of the rotary in that you could modulate the engine in the SE5A up and down, but it did give you something else to think about. So horses for courses. The biggest, I read a book on First World War airplanes, and the biggest criticism of the SE5A was its armament. And the pilot said, whoever in their right mind put two different guns on a fighter? He said, because you got to, and he said, I bet the person that put the Lewis on the top never tried to change the magazine in flight. He said, have you ever tried to put a magazine on an airplane as a flat plate, a circular flat plate, a foot in diameter, in a 90-knot wind, and push it forward to get it onto the gun? And if you think about it in that context, must have been absolutely bloody impossible to get the magazine on the gun in a combat area. So there we go.
I read an account of somebody, I don't know how true it is, that was trying to change the drum on the Lewis gun, and the plane went inverted and he fell out.
Yeah, that was a chap called Strange.
Oh, right.
Yeah.
Yeah. Anyway, he managed to survive, obviously, to tell the tale. Yeah,
the magazine jammed, so he ended his strap so he could get a bit higher to unjam it, and the aircraft turned over and he ended up hanging on to the magazine, the story goes. Luckily it didn't unjam, and he managed to get back into the cockpit again.
Yeah, amazing. Alex got one. How long does it take for a Shuttleworth pilot to convert to rotary aircraft?
Get training hours as such? Yeah, we get as much training hours as we need to train the pilots. I used to keep the minimum number of pilots current, plus one. So if somebody fell over, then we've always got a spare ready to go. And it normally took a good briefing and a flight or two in the airplane, about 10-minute flight. The 504, very easy aircraft to fly with a reasonably easy rotary to operate. And we'd put the pilots on that to start with. So it didn't take very long at all. By then, the pilots had gone through most of the collection types, and they were quite au fait with the operation of older and more, I wouldn't say difficult airplanes, but trickier airplanes to fly. So the rotaries were the last set of aircraft that you put somebody on, and they'd gone through so many stages of going backwards that the only difference was the engine, and the engine, after a good briefing, is relatively simple to operate.
Yeah, I have a question.
Yeah, go on, Mark.
I visited the vintage aviator pilots at Masterton when they had a training session down there, and they had a replica First World War aircraft which had a Lycoming in it, and their whole way of doing it was for the pilots to fly that first to get used to the handling characteristics, and do the engine management training after they got used to the handling characteristics of the aeroplane by flying the Lycoming engined one, which of course was just like a modern aeroplane as far as engine management went. You don't do it that way, I guess.
Well, not at the Shuttleworth. All of the aircraft, they try and get a authentic engine in. So yeah, there's all of the rotary powered aircraft have got rotary engines, but by the time you get onto a rotary, Sopwith Pup, Sopwith triplane, Bristol monoplane, for example, you will have flown the SE5A and the Bristol F2B, which are both World War I airplanes. So they'd be quite used to handling characteristics of that type. They might even have flown the box kite and the Avro triplane. Avro triplane's got wing warping, but a conventional motor on the front. The box kite should have a rotary, in fact, but it's got a Rolls-Royce 0200.
Okay.
But the box kite is quite a tricky airplane to fly. It's unstable in pitch, unstable in yaw, and neutrally stable in roll. So that can be quite a challenge. Be quite fun as well. As one of my colleagues said, you can float around the countryside at 35 miles an hour watching all the traffic accidents you're causing as people look up to watch you. Are there any simulators that I pilot against these? Not that I'm aware of. Flight simulators on PCs are one of my soapboxes. I did work as a flying instructor for a time. And if somebody said, oh, I want to say, how much flying have you done? None at all, but I've done a lot on the PC. You think, oh, God, no. Because the way to fly an airplane, as you know, is visually. Cover up all the instruments and look out the window at the horizon and fly it relative to the horizon. Now, most of the older airplanes don't have instruments. The Blackburn's only got the Blair Air's got an oil pressure gauge. The Blackburn's got an RPM gauge. The Deperdussin has got a fuel gauge, but that's all. And so you have to fly them visually. And if you fly them visually, they fly rather well. If you start messing about with instruments, they don't. So no, there isn't. You'd need a full mission simulator to do it, and they don't exist for the old stuff. They only exist for the new stuff. There's a Wright Flyer simulator in the Smithsonian, is there? I've been there, been to the Smithsonian, but I didn't know there's a Wright Flyer simulator there. I have flown the, oh, cracky. I can't remember what it's called. Space Shuttle. Flew the Space Shuttle simulator at NASA when I was doing some research into hot gas ingestion. We used their simulator at NASA Ames in San Francisco, but never flew the Wright Flyer.
Is there any aircraft you would love to have flown that you haven't had a chance to?
Yeah, Mosquito and ME-109E, but it's unlikely. I did get offered the Mosquito over in the States, actually.
Well, there's a chance because there's a few flying now, isn't there?
Yeah, I'm not going to do that anymore. I haven't flown a historic aircraft for, well, the wife's got an Oster, but I haven't flown that for about 8 years. The last Shuttleworth aircraft I flew was in 2009. Not flown any. So the only things I've flown since about 2010, Cessna 172, Cherokee, Aztec, and Hercules, which suits me fine. That'll do. Don't need to fly them anymore.
Is there any one aircraft you've walked away from and gone, thank God I don't have to fly that again?
Yeah, the Buccaneer.
Really?
Yeah. God, bloody awful thing. A lot of my friends, but I chose Buccaneers when I went through Valley in the Air Force. In my day, you did Jet Provost, got your wings, you went to Valley and did the NAT. And then you chose where you were going to go. And then you went to Brody on the Hunter, and then you went to your operational conversion unit. And I put Buccaneers first choice, Phantom as second choice, Hunter as third choice, and anything but Jaguar as fourth choice. And you can guess where they sent me. So there we go. But I flew the Buccaneers as a test pilot at Boscombe. And the only thing it does better than a Jaguar is go further. The Jaguar has got a better turning performance, better acceleration, better top speed, better weapon carriage, better weapon aiming, better takeoff, better landing, the whole gambit, better field of view as well, and so on and so forth. Yeah, Buccaneer's a bit of a lump, really is. Probably best we don't go there. I do tend to offend people with my views on airplanes.
I was going to say I've got some friends that have got Buccaneers. They don't fly now, but
yeah, they would disagree.
they would.
The interesting thing is you've got to look at it as an objective or a subjective assessment. And if you look at it, I mean, ask a Lightning pilot what the best airplane is, and the Lightning is the best thing that ever hit the world. And the same with Buccaneer pilots. They had a lot of fun flying it. They had a great role, and they really enjoyed it. Therefore, the Buccaneer is the best thing that ever hit the world. But if you look at it objectively as a test pilot, they're both bloody awful. They really are. But that's by the by. It's a difference between a subjective and objective assessment.
Yeah. Okay. Anyone else? Any more questions? Looks like that's it then. Well, I'd just like to say thank you very much, Andy. It was a very enjoyable evening.
You're welcome.
And, well, let's hope we all get flying again soon. So with that, I'll call it to an end.
Okay. Well, thank you very much indeed. Thanks for listening.
Okay.
Right, all, and thank you, Andy. Superb.
You're welcome.
Cheers.